With Starbucks Holiday Blend for Nespresso Virtuo, now exclusively at Target, there are even more ways to share the joy. Savor every smooth and festive sip all holiday season with friends and family at home to fill every indulgent day with cheer.
Welcome to the Agrihood. Carnes Crossroads is a new home community with a farm-to-table lifestyle. Just outside of Charleston, here, community is defined by gathering together and our deep connection to nature. Our future farm and amenities are taking root and blooming into something you've always dreamed of in a fun, healthy, and social environment. Come home to the Agrihood, where you can plant roots and thrive.
Learn more at carnescrossroads.com.
This is SpaceTime, Series 23, Episode 115, full broadcast on the 30th of October 2020. Coming up on SpaceTime, the BepiColombo's spacecraft undertakes its first flyby of the planet Venus, problems worsen aboard the International Space Station, and China carries out its first orbital sea launch. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The BepiColombo mission has completed the first of 2 Venus flybys needed to set it on its course for the solar system's innermost planet, Mercury. The closest approach of the flyby saw the spacecraft swoop down to within 10,720 kilometres of the planet's surface. BepiColombo needs 9 gravity-assist flybys. The first was with the Earth. There are 2 with Venus, and then 6 with Mercury, before finally achieving orbit insertion. These flybys utilise the gravitational pull of the planets to help alter the spacecraft's speed and direction, and together with BepiColombo's on-board solar electric propulsion system, helped to steer the probe into Mercury orbit against the strong gravitational pull of the Sun. The first flyby, that of Earth, took place back on August the 10th. In the process, BepiColombo returned some stunning images of our home planet at a time when our world was coming to realise the extent of the lockdown needed due to the COVID-19 coronavirus pandemic from China. In fact, thanks to COVID-19 for the Venus flyby, mission managers were forced to conduct the majority of their preparations through teleworking from home, with only a minimal crew at mission control during the flyby to ensure the safe operation of the spacecraft. 2 of the 3 monitoring cameras aboard the Mercury transfer module were activated before closest approach, and 7 of the 11 science instruments aboard the European Mercury planetary orbiter, plus its radiation monitor, and 3 of the 5 instruments aboard the Japanese Mercury magnetospheric orbiter were also active during the flyby. While the sensors are designed to study the rocky atmosphere-free environment of Mercury, the flyby nevertheless provided a unique opportunity to collect some valuable scientific data about Venus. Scientists hope to have collected data on Venus's atmospheric temperature and density profiles, information about the chemical composition and cloud cover, and new observations of the magnetic environment interaction between the Sun and Venus. And they're hoping for even more research data during next year's second Venus flyby. That'll happen on August the 10th, and we'll see the spacecraft fly just 550 kilometres above the planet's surface. After the August close encounter, BepiColombo will make its first Mercury flyby in October next year, passing at a distance of just 200 kilometres above Mercury's surface, in the process providing the first tantalising taste of what will follow once the mission's 2 science orbiters have arrived at their dedicated orbits around the planet. There, they'll study Mercury's evolution, the nature of the ice in the tiny planet's shadowed craters, why it retains a magnetic field, and whether it's still geologically active. BepiColombo was launched aboard an Ariane 5 rocket back on October the 20th, 2018 from the European Space Agency's Kourou spaceport in French Guiana. The spacecraft consists of 4 sections that will detach at specific points along the mission's journey. The 2 primary sections are the European Mercury Planetary Orbiter and Japan's Mercury Magnetospheric Orbiter, which will each orbit Mercury at different altitudes. ESA's Mercury Planetary Orbiter is designed to analyse the planetary surface and composition, while JAXA's Mercury Magnetospheric Orbiter will explore its magnetosphere. A third section, the Mercury Transfer Module, is located at the base of the stack, and it supplies power and support for the two orbiters, as well as propulsion during the cruise phase of the mission, and it will protect the two orbiters from the extreme temperatures as they get close to Mercury and the Sun. The fourth section is the magnetospheric orbiter sun shield and interface structure. It's fitted between the two orbiters and will further protect the Mercury magnetospheric orbiter before it enters orbit. It'll enter orbit around Mercury on December 5, 2025, studying the planet's structure, its magnetic field, the surrounding near-space environment, its interaction with the near-solar environment, and the solar wind. This is SpaceTime. Still to come, problems worsen aboard the International Space Station, and China carries out its first ever ocean launch of an orbital spacecraft. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Well, things have been getting, shall we say, interesting aboard the International Space Station of late. Russian mission managers say the orbiting outpost is working normally at the moment with no threat to the safety of the crew, despite a spate of problems and equipment failures. Firstly, there was the air leak in the Russian Zvezda module, which has been allowing atmosphere to slowly vent into space. That's been an ongoing issue for more than a year now, but it started to get significantly worse in recent months. It took ages, but the crew finally traced it to a crack in one of the Zvezda compartments. And after initial efforts to repair it failed, follow-up efforts were finally successful. However, the problems didn't end there, with the Zvezda module's water system, which supplies the oxygen to the Russian segment of the space station, also failing, thereby putting extra load on the oxygen system on the American side of the orbiting outpost. Then Zvezda's food heating system also failed, as did the usually reliable Russian toilet aboard Zvezda. Now, as if all that wasn't enough to worry about, the space station crew have also reported an unexpected increase in temperature inside the Zvezda module. They say the temperature began to slowly rise over several days. The Russian Federal Space Agency Roscosmos says all systems are now working again and there's no danger to any of the personnel on board. Still, these problems have arisen as concerns continue to grow over the age of the Zvezda module, which is now more than 30 years old. It was originally built back in the mid-1980s to be the core module of the then-proposed Soviet Mir-2 space station. When Moscow decided to join the International Space Station project, it cancelled Mir-2, mothballing Zvezda until it was finally launched in the year 2000 to become part of the International Space Station. Veteran Russian cosmonaut Gennady Padalka says all the modules on the Russian segment of the space station are now exhausted and well past their use-by dates. He says the equipment should only be used in orbit for around 15 years. This is SpaceTime. China has carried out its first ocean-based space launch, sending a Long March 11 rocket into orbit from a floating launch pad in the Yellow Sea. A specially modified barge was stationed 400 kilometers north of Shanghai, just off the coast of Shandong. The Taiyuan Satellite Launch Center controlled the launch from the mainland. The solid rocket-powered Long March 11 successfully placed 9 satellites into orbit. Launching rockets at sea offers several advantages over land-based launches, including ensuring that spent rocket stages don't fall on land, threatening life and contaminating areas with toxic fuel. And by stationing the launch pad on or near the equator, it also allows you to lift greater payloads for a given amount of fuel. That's due to the added boost provided by the increased speed of the Earth's rotation at the equator. China is only the third nation to launch orbital rockets from the sea. There was, of course, Sea Launch, which focused on launching large geostationary telecommunications satellites on Russian-Ukrainian Zenit 3SL rockets. Based in Long Beach, California, Sea Launch vessels included a control ship and a mobile launch pad converted from a Baltic Sea floating oil platform. The rocket will be processed aboard the control ship and then transferred to the launch platform, with launches taking place on the Pacific Ocean equator south of Hawaii near the islands of Kiribati. Years earlier, between 1967 and 1988, NASA and the Italian Space Agency also conducted 9 orbital launches using a range of rockets from the San Marco launch platform, a former stationary oil platform located just off the coast of Kenya. Mission control was located on the nearby Santa Rita oil platform, while a smaller Santa Rita 2 platform housed the facility's radar, and a ground station located on the nearby mainland provided primary telemetry. The entire complex has since been converted into a satellite communication station. This is SpaceTime. Still to come, the growing popularity of amateur astronomy, and later in the science report, a new study shows that this year's ozone hole over the Antarctic is one of the largest and deepest in recent years. All that and more still to come on SpaceTime. Amateur astronomy's always been popular, and that popularity's been growing over recent months thanks to the lockdowns associated with the COVID-19 coronavirus. It's a great way to keep kids occupied while at the same time being educational and expanding their minds. Plus, adults tend to like it too. Another important feature is that amateur astronomy is one of the last sciences that's still accessible to ordinary people, allowing them to enjoy the wonders of the universe and even become citizen scientists, helping professionals carry out real research. But what really makes it so popular is its accessibility. It's an inexpensive hobby to carry out. After all you really need is a patch of sky and a pair of binoculars. There are thousands of astronomy clubs around the world offering advice or in some cases courses on how to navigate the skies, how to use inexpensive backyard telescopes, or even how to build your own telescope. And as you get more and more into it, you can progressively accumulate more and more sophisticated equipment. This month's issue of Australian Sky and Telescope magazine has a special feature on amateur astronomy. And joining us now with the details is the magazine's editor, Jonathan Nally.
Stuart, in this month's issue of Australian Sky and Telescope, we have lots of info for the amateur astronomer and all the different aspects of the hobby. So we've got articles on how to improve your night sky images, specifically by taking multiple images and adding them together, which is what they call stacking. You can get a lot more detail and nicer images by doing that. And with the electronic cameras and things you've got these days and free software you can use, it really makes it so easy. If you're into planets, we have lots of hints and tips in this issue on how to observe the planet, including which kind of filters you might need to use to bring out detail in the planetary atmospheres. We've got a fabulous design for a portable telescope that has all the bells and whistles, but it all folds up neatly into a compact unit for transport or storage. You wouldn't even know there's a telescope inside, really. It's just so compact. But you can take all the pieces out, put it together in a couple of minutes, and away you go. So
is it hard to build a telescope? I mean, I would have thought that would have been a really difficult thing to do.
It depends on your telescope. Yeah, look, some telescopes are really easy to build, others a bit more complex, and it has to be said that this particular design that we feature in this issue, this fellow's pretty experienced, and I think it's probably his third attempt at making a scope like this. But that doesn't matter. I mean, it's great, something to look forward to and something to aspire to, and you don't even have to do it exactly like he's done it. There are so many people that have done different designs of telescopes over the years. They're all basically the same, but he's just done it a really clever way.
What is it, a Dobsonian or something?
It's a Dobsonian basically, yeah. So it's a reflector telescope in a Dobsonian mount, but with a few differences, so that it can all pack away inside itself, basically. So have a look at that. That's really incredible. And we have a review of a fantastic new telescope, a special kind called a hyperbolic astrograph. I don't mean that's a new kind of telescope. They've been around for a while, but this is a new brand and a new model they've got out. And a hyperbolic astrograph is great for taking optimized wide-angle images of celestial objects, such as galaxies and nebulae, and it gives you nice, crisp detail all the way to the edge of the photographic frame, because some optical systems you get a beautiful crisp image in the middle, but towards the edges of the field it can be a little bit distorted. But this thing, being a hyperbolic astrograph, is just really, really good.
Does that come down to the type of optics it has? I mean, mirrors and lenses, or what?
Yes, it does. Yeah, it's a combination of mirrors and lenses that they've used, and the quality of the materials, and the exact specifications of focal lengths and things. There's an endless variety of telescopes, and they've optimize this particular design with a particular focal length and a particular diameter tube and everything, and the particular materials they've made it from, for doing one purpose, which is really taking spectacular photographs. So you wouldn't necessarily use this telescope to do just general observing with. It's for people who just want to take really specky photos, and there are plenty of people out there who want to do that.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. Today's edition of SpaceTime is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
You're listening to SpaceTime with Stuart Gary.
And time now to take another brief look at some of the other stories making news in science this week with a science report. New measurements show that this year's ozone hole over the Antarctic is one of the largest and deepest in recent years. The new measurements by the European Space Agency's Copernicus Sentinel-5P satellite show that the ozone hole reached some 25 million square kilometres in size on October the 2nd. The size of the ozone hole fluctuates on a regular basis, usually increasing between August and October. The variability of the size is largely determined by the strength of a strong wind band that flows around the Antarctic. This band is a direct consequence of Earth's rotation and the strong temperature differences between polar and more moderate latitudes. When the temperatures high up in the stratosphere start to rise in the southern hemisphere, the ozone depletion slows, the polar vortex weakens and finally breaks down, and ozone layers return to normal by December. Ozone's important for our survival because it provides a protective shield against ultraviolet radiation from the sun. During the 1970s and 80s, scientists found that chlorofluorocarbons, or CFCs, a group of chemicals used in products ranging from refrigerators to aerosol cans, were destroying the ozone layer. That led to the adoption of the 1987 Montreal Protocol, which called for the phasing out of chlorofluorocarbons globally. And for the most part, the world has supported that ban. However, a report in the journal Nature found that China's continuing to pump huge amounts of chlorofluorocarbons into the atmosphere from industries in its eastern provinces despite the international ban. Scientists have improved the output of a device designed to extract drinking water directly from the air. The device, reported in the journal Joule, could become a practical water source for remote areas with limited access to water and electricity. It works by harnessing a temperature difference within the device to allow absorbent material, which collects liquid on its surface, to draw in moisture from the air at night and then release it the next day. When the material is heated by sunlight, the difference in temperature between the heated top and the shaded underside of this material causes water to condense out of the material and drip onto a collection plate. But the device required the use of specialized materials called metal organic frameworks, which are expensive and limited in supply. Now, by incorporating a second stage of desorption and condensation, and by using a readily available absorbent material called zeolite, composed of a microporous iron alumina phosphate, water output was significantly increased. A new Japanese study claims that drinking green tea and coffee may help people with type 2 diabetes live longer. The findings, reported in the British Medical Journal, showed that drinking 4 or more cups daily of green tea plus 2 or more of coffee was associated with a 63% lower risk of death over a period of 5 years. Researchers found that those who drank just 1 cup of green tea or coffee still had a lower risk than people who didn't drink either beverage. But the benefits seemed to increase with the more cups people drank. A series of studies reported in the Journal of the American College of Cardiology has been examining how the COVID-19 coronavirus is affecting the human heart. Around 1 in 4 people hospitalized with COVID-19 end up having heart damage caused by the virus. The studies included one which has identified a new COVID-related cardiometabolic syndrome, driven by patients having high body fat, unstable blood sugar, high levels of fats in the bloodstream, and high blood pressure. Lifestyle change is recommended for these patients, as well as a course of drug therapy. A second study looked at the global concerns COVID-19 has raised for the health and safety of heart disease patients. Scientists found that COVID-19 survivors will be more vulnerable to death from heart problems in the future once the disease is cleared. And a third study was looking at the damage which COVID-19 causes to the heart, including blood clots and irregular heart rhythm, both of which can be fatal. Some 43 million people have now been infected and well over 1 million killed by the COVID-19 coronavirus since it first made its way into the community in Wuhan, China a year ago. Well, it now seems the most likely explanation for the origins of the COVID-19 coronavirus involves a catastrophic security breach at the Chinese Liberation Army's Wuhan Institute of Virology experimental laboratory. The Level 4 biolab, the only one in China, was conducting research on horseshoe bat SARS-CoV-2 viruses at the time. And earlier inspections of the facility by a US delegation found evidence of poor biohazard security. Then there's the curious fact that those at the Wuhan lab were ordered to destroy all their research and sanitize the entire facility immediately after the outbreak, effectively destroying any evidence. Meanwhile, the nearest wild populations of horseshoe bats with the same SARS-CoV-2 strain from which COVID-19 originates are located some 1,600 kilometres away, so it's unlikely the bats flew to Wuhan by themselves. And that leaves Occam's razor. The most straightforward explanation is usually the most likely. However, not everyone's convinced. One group believes the deadly virus may have been extraterrestrial in origin. Tim Mendham from Australian Skeptics says they literally believe that COVID-19 came down in the last shower. The last meteor shower, that is.
Everyone's looking for a sort of where did it come from solution. Obviously, most people would say it came via the wet markets in China. Others, of course, saying that it came through, it was from research labs, it was artificially created. Or it could come from 5G, of course. I never quite figure out how it could come from that, but, that's been suggested as well. But one that crops up a lot with viruses and pandemics and that sort of thing is that it comes down from outer space.
So this is the panspermia theory.
Exactly, panspermia. And basically, there's an institute for the study of panspermia and astroeconomics in Japan. And they and various others have suggested that COVID has come down through comets or whatever from outer space. And as I said, this crops up quite a lot. It has cropped up in the past when there's been previous pandemics, etc. Tends to be the same people making the claim. And one of them is a fellow named Chandra Wickramasinghe, who has a long history of making. He has been around for a long time. He used to do a lot of work with Fred Hoyle, the scientist and science fiction author, who wrote a book called
astronomer.
Who wrote a book called The Black Cloud.
Indeed.
And that was about the sort of danger. And he and Wickramasinghe had been working a long time in these things, and Wickramasinghe is still around and still making these claims. And it's been pretty well sort of dismissed. One commentator said that he's been around so long that he doubted there was any disease he didn't think came down from outer space. So it's not really going anywhere at the moment, and it hasn't in the past. Although, there's always been suggestions that life might have come down from outer space in the first place, rather than being spontaneously created on Earth. So, keep an open mind about it, but perhaps only a small open mind.
How do they respond to the fact that the DNA strain of COVID-19 that we're looking at does in fact come from horseshoe bats? Did the bats come from outer space as well?
I don't know. I think what we're seeing is people who have a particular theory and are fitting the cases to them. And I haven't seen a report on how they responded. It's basically just something that was published or proposed, if you like, by these various groups in Japan and the UK, even China and Canada. So they've got together. I should actually add there's one in Melbourne too, University of Melbourne.
Okay. So,
and they've published this paper.
Well, it gives us some legitimacy then if there are that many scientific institutions supporting it. It can't be simply ruled out then.
It can't be ruled out of order entirely. The thing is trying to find the evidence for it. Like 2 decades ago, Graham claimed that flu came down from space, and this was roundly criticised as bunk. He also claimed that SARS had the same origin. So basically, it's like any disease that's coming down, especially the pandemic-type diseases, these source from outer space.
Well, he must be bolstered by the discovery of chemicals in the Venusian atmosphere, which could most likely have come from life.
Phosphine, which is a gas that is supposedly sourced from life forms. So therefore, its existence in the atmosphere of Venus
it can be made artificially as well, but
the question is it really there? What's the circumstances? Blah blah blah. It's very, very early days for that one. So, but how it got from there to here would be a different issue as well.
Well, that's where panspermia comes in.
That's where panspermia comes in. Yeah.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.